Hello everyone, this is Akshay Jain and today I'll be presenting on one of the fundamental concepts in computer graphics, drawing algorithms, particularly line drawing algorithms like DDA and Breshanham'S. Let's proceed. So what are drawing algorithms? The first question which arises in our minds is what are drawing algorithms? So in order to understand drawing algorithms, line drawing algorithms, we first need to understand what are drawing algorithms. See, if you want to create any shape in computer, the shape which you view on your computer are all approximated by pixels, and for that a line drawing algorithm decides which pixels best represent geometric shapes on a raster display. Since screens are made up of pixels, we need algorithms to approximate continuous lines. As you can guys see on your screens is a line approximated by pixels. This is a line approximated by pixels. Now let's proceed. Why do we need them? So a very straightforward answer to a very straightforward question. We need them to draw shapes, to draw certain shapes, to draw any shape on your computers, or to view any shape which you view on your computer are drawn with the help of these algorithms. To draw shapes in more accurate and more efficient ways, we need line drawing algorithms or just drawing algorithms. Here are some points. Digital screens are pixel based. Yes, this is digital screens are pixel based, so we need certain algorithms to draw any shape on them. We need efficient and accurate ways. Obviously we need efficient, more efficient ways to draw shapes. And real-time applications, yes, they have a real-time applications. Types of line drawing algorithms, these are the ways by which we draw any shape on particularly the lines on computer screens. There are three commonly used drawing algorithms, but we'll see only two of them in this video: DDA, digital differential analyzer, and Breshanham'S line drawing algorithm. So let's proceed. Now let's explore DDA first. DDA, digital differential analyzer algorithm, is a line drawing algorithm used in computer graphics to generate a line segment between two specified points. Suppose you have 2 points, a starting point and end point. Now you want to generate a line. To generate a line, you need only 2 points, the starting point and the end point. And digital differential analyzer uses these points and create a line segment between them and creates a line. DD algorithm is relatively easy to implement and is computationally efficient, making it suitable for real-time applications. However, it has some limitations such as inability to handle vertical lines and the need for floating point arithmetic, which can be slow on some systems, which we'll talk ahead in this lecture. Let's proceed. Algorithm. So let's see algorithm. Step 1, start. Step 2, we consider starting point as x1 y1 and ending point x2 y2. Step 3, now we have to calculate delta x, which is change in x, and delta y, which is change in y. The change in the coordinates x1, x2 and y1, y2. This is the change which we'll calculate by delta x, x2 minus x1, and delta y, y2 minus y1. And m is the slope, as we know, which is delta y upon delta x. Now step 4. Now we calculate three cases. The value of m further takes us to three cases. We calculate the value of m, which is very important because it proceeds to the three cases. Let's see the cases. If m is less than 1, then x change in unit interval, y moves with deviation. If m is greater than 1, then x moves with deviation, y change in unit interval. And if m equal to 1, then x moves in unit interval, y moves in unit interval. Which means if m is equal to 1, slope of the line is 1, x is incremented by 1, y is incremented by 1. If m is greater than 1, then x moves with deviation and y moves in change in unit interval, which means y only increases by 1. And here in the first case where m is less than 1, x change in unit interval, which means x is incremented by 1 and y remains the same. So let's proceed. Let's take an example to understand the DDA more efficiently. Uh, let's see the example. For line segment between 1 7 and 11 to 17, we have two coordinates here, starting points which is 1 comma 7 and ending point which is 11 comma 17. Firstly we calculate change in x, which is 11 minus 1, that is 10, and change in y, which is 17 minus 7, that is also 10, which provides us the value of slope m, that is 1. Now let's recall the first case which we studied. Case third, sorry, it was third case, my mistake. If m equal to 1, now here in the next slide m is equal to 1. So what was the rule there? X moves in unit interval, y moves in unit interval, which means m is incremented by x is incremented by 1 and y is incremented 1. Let's look at a table to understand that this more clearly. Now here our xk and yk in the beginning points are 1 and 7, and then uh, x is incremented by 1, y is incremented by 1, which gives us intermediate points 2 comma 8. Again 3 comma 9, 3 is incremented by 1, 2 is incremented by 1, 8 is incremented by 1, and here we repeat this process until we reach the ending point, starting point from ending point. Until we reach the ending point we repeat this process. Here it is written the same thing, that we will repeat step 3 until we get the endpoints of the line. Step 5 is stop. So let's see our points on the number line. See, it's 2 comma 8 and it's up to 11 comma 17, and these are our intermediate points, which are 3 comma 9, 4 comma 10, 5 comma 11, 6 comma 12, 7 comma 13, 8 comma 12, 14, 9 comma 15, 10 comma 16, which you can guys see on your screens. Let's move further then. Now we'll see Breshanham'S line drawing algorithm. The algorithm helps us to perform scan conversion of a line. It is powerful, useful, and accurate method. We use incremental integer calculations to draw a line. The integer calculations include addition, subtraction, and multiplication. In Breshanham'S line drawing algorithm, we'll calculate the slope m between the starting point and the ending point. We do the same thing in the Breshanham'S. We calculate m, we calculate change in y, change in x, then m. But there are certain changes in rules in the value of m, which further decides our output. So let's see its algorithm. Start. Now we consider starting point, ending point. Now we calculate delta x, delta y, which is same as the DDA. But here comes the different thing, which is here pk. Pk is the decision parameter. Now its value is 2 delta y minus delta k. It's a bit of complex than DDA. DDA is very simpler algorithm, which is very simple to understand, but it includes quite of complications, which we look. So the initial coordinates of the line are xk, yk, and the next coordinates are xk plus 1, yk plus 1 here in the first case. Now then the pk's value will define the further proceeding. Case 1, if pk is less than 1, then pk plus 1 equal to pk plus 2 delta y, xk plus 1 equal to xk plus 1, yk plus 1 equal to yk. Case 2, if pk is greater than equal to 0, then pk plus 1 equal to pk plus 2 delta y minus 2 delta x, xk plus 1, xk plus 1, yk plus 1 equal to yk plus 1. Now let's move on to example to understand it clearly, because the reading the algorithm would not be able to clearly define it. Step 6, we'll repeat this step 5 until we found the ending point of the line. Total of iterations, here we can also count here total number of iterations, and step 7 is stop. Let's look at our example. A line has a starting point 9 comma 18 and ending point 14 comma 22. we have two coordinates here, starting point x1 y1, ending point x2 y2, which is 9 comma 18 and 14 comma 22. We'll calculate delta x delta y, which I have previously explained in the DDA. Step 2, now we are going to calculate the decision parameter. Decision parameter is as we can look here in the previous slide, pk plus 1, pk equal to 2 delta y minus delta x. Here, now we'll go calculate the decision parameter, which comes 3, which means here the first case is satisfied, del pk is, no, the second case is satisfied, pk is greater than equal to 0. Now if it is greater than 0, then we have the value of pk plus 1, that is pk plus 1 equal to 1. Now let's look at the table to understand it more clearly. Now step 4, next, now move to next step, we'll calculate the coordinates until we reach the end point of the line. We'll repeat this step 3 until we reach the end point. Here pk plus 1, xk plus 1. Now we have the starting point as 9 comma 18. We have the value of pk as 3. Here we have the value of pk as 3, and value of our xk plus 1 and xyk plus 1, 9 comma 18, which means the first case is satisfied, and we'll increment the value by 1 and 1. We incremented it. Now the next pk is, we calculate the next pk, which is calculated by the same formula here, this formula, using these values, using these values using these values. And now we'll calculate, we'll increase, now the outcome is again positive, so we'll increment it by 1 and 1. Then we'll use these values in again this formula, this one, and now it comes minus 1. And if the value is minus 1, if the pk comes minus 1, then we'll increment the xk, but our yk will remain same. Now again the value comes positive, so we'll increment it by 1, we'll increment it by 1. Again the value comes 5, we'll increment it by 1, we'll increment it by 1, and we reach our endpoints here. Therefore our calculation stops here. I think you got it. Step 5, stop, which is we reach the endpoints. Here this is the starting point, which is 9 comma 18, and this is the endpoint, which is 14 comma 22. Now we'll proceed comparison. So now we can clearly see here, if performance is critical, then Breshanham algorithm is preferred, but for teaching or simple implementation, DDA is easier. You can also read here certain difference points. Calculation, yes, it uses floating point, and it uses integer. Its accuracy, it's moderate, it's high. Speed, it's slower, it's faster. Best for simplicity, it's best for performance. If you want performance, if you seek performance, then Breshanham is preferred. But if you seek simple implementation or for teaching purposes, then DDA is quite easier, quite understandable. And yes, thank you.